Good morning, everybody. Welcome to Yeast Management Best Practices for Dry Hop Beers. I'd like to introduce our speaker, Dr. Allison Lange. Allison is the R&D molecular biologist at Omega Yeast in Chicago. She graduated from Dartmouth College with a degree in genetics, cell, and developmental biology, and was awarded a PhD in biochemistry for Emory University. Allison has brewed professionally for 9 years, and she began as a brewer and beer scientist at Port City Brewing in Alexandria, Virginia. Then moved to be director of brewing operations, lead brewer, lead QC, lead cellar person at 3 Stars Brewery. Wearing a lot of hats, it sounds like most of us tend to do. Most recently, she was head brewer of Old Ox Brewery in Ashburn, Virginia. So please welcome our speaker.
Thanks so much for that nice introduction. Like Hutch mentioned, today we're going to be talking about yeast management practices for dry hop beer with a big focus on the dry hop part. So a lot of what we're going to be going through are things that are specific to the kind of beers that we're making these days. So it might be hazies, might be West Coast, might be Italian Pilsners, all these good kind of interplay we have between our yeast and our hops. He did a really good job of introducing who I am. I'm sure a lot of you are familiar with who Omega Yeast is. We're a yeast provider out of Chicago, and our biggest mission is to be as helpful as we can. So give us a call. We're happy to answer whatever you want. We just recently had somebody calling about how to repair their heating elements on their kettle. We helped them out, so give us a call. It all comes back circles somehow. So, yeah. So how this talk's going to be structured today is we're going to start out talking a little bit about how to choose your yeast, why yeast management is important. And then the bulk of this talk is going to be about some of the more high-level stuff that's going to affect dry hop beers. So a lot of it's going to be on hop creep, and then a little bit on haze, because these are kind of things that are going to affect our dry hop timing as well as the yeast strains that we're using. And then we're going to bring it all back together and go back into some good practices for how to actually deal with our yeast. So why is yeast management important? When it goes wrong, you can get bad fermentations. You can get production of off flavors, so diacetyl, sulfur compounds, acetaldehyde, fusel alcohols. You can also get poor yeast health, and that leads to either autolysis flavor, poor foam stability, poor clarity. But when it goes right, we're all really happy about it, right? So we get predictable fermentations, consistent ABVs, quality control, all that department is healthy, is happy with us. Minimal off flavors, shorter diacetyl rests, reliable turn times, and all of that turns into us saving money and making good beer, which is all we really want to do. As far as how to choose your yeast, things that are practical considerations, these are the kind of things that people call us with. They come to us with a beer idea and ask for suggestions for strains. The things you want to look for are versatility. So can you use it in other strains in your brewery or in other beers? Does it suit your production needs? So does it fit your turn time, your repitching schedule? Is it easy to harvest? Does it flock well? Is it easy to store? So can you keep it in your cooler for a while, or is it one that you're going to start getting like hammy, meaty flavors off of? How reliable is it? So can you use it from gen to gen? Do you get the predictable flavors that you think you're going to get out of it? Is it easy to source? So do lots of different vendors sell it? If you run into a problem, are you going to be able to get it from somebody else? What are the lead times? What's the quality of the pitches you're getting? And then what's the cross-contamination risk bringing this into your brewery? So is it phenolic? Is it diastatic? Is it a Brett? Is it something where you're going to have to figure out a new cleaning regimen in order to bring this into your brewery? Like, can it go through your canning line, for example? That's something you definitely want to think about. Considerations for hop-forward beers are how this yeast is interplaying with haze. So is it a haze-promoting yeast? Or is it bright? Will it drop out? Does it flock well? Or is it kind of powdery? Also, what kind of metabolites are produced. So certain strains obviously are prone to having different kinds of off flavors. Other ones, produce a lot of esters. That's something we actually want sometimes if you're making like a hef. And then can it do biotransformation? So is it doing the things to hop compounds that we think that it should? Take into account the attenuation and the ABV tolerance, and then its oxygen requirements. So we know for some of these hazy strains, for example, that you need to bump up the oxygen in order to get the effects that you think you're going to get. As far as dry hop beers, these are some of the common strains that get used for these things, depending on the style that you're making. We have a kind of a variety of things going kind of up the clean scale and down the juicy scale, and you kind of can take into account what you're trying to make when you're picking these things. So there are some unexpected ones that, for example, are haze positive. So Pulse 2, for example, is one that I think not everybody thinks about as a haze promoting strain. But if you are looking for something that is not your London 3, British 5, or your Voss, you might want to play around with Kolsch 2, for example, in those beers. So there's a lot of options out there. Definitely talk to whoever your yeast provider is, because you can find a good mix for you that matches your haze, your esters, your attenuation. And then keep in mind any of the sort of random stuff that comes along with these things. So, some of them might be prone to sulfur or diacetyl. Doesn't mean you can't use it. It just means it's something you need to take into account as you're building your beer. All right, so I said the major thing we're going to talk about is some of these more high-level things when it comes to hopping our beers. So the first thing we're going to talk about is hop creep. So a little history on hop creep. People have known about this for a long time and then forgot about it. So in 1893, Horace T. Brown, who was a killer beer biochemist back in the day, I believe he might have founded Guinness's lab. If not, there certainly is a scholarship at Guinness that is named after him now. But he published a paper on the freshening power of hops. And the idea there was that you got a re-fermentation. So people knew about it back in the 1800s. About 50 years later, there was a study where they talked about maltase in hops. So they saw this breakdown then. And then it wasn't until about 120 years later that we really started thinking about it again. So Tom Shellhammer's lab in Oregon is one of the main kind of scientists who's pursuing this kind of a thing, as well as some of the bigger labs who first saw this. Basically what happened is, they were seeing creep in Pliny, and they had the scientists actually pay attention to it. So they were keeping really good records, they were finding unexpected results. For example, Allagash, I think, had to dump their first batch of hoppy table beer because they put it into the package for natural carbonation in the package, and rather than getting the 2.5 volumes they thought they were going to get, they got about 4.5. And I mean, Allagash knows how to bottle condition. This is not like a mistake in calculations. This was an effect that they didn't take into account, or they didn't really know about or didn't think about, because they're not putting that much hops in beers usually, like a dry hop like that. And so they had to go back and figure out kind of what was the problem in that. And it turns out it was dry hop creep. So our current understanding of hop creep is that in your finished beer, you have a certain subset of unfermentable dextrins and maltodextrins. So you go through, the yeast finishes eating all of the glucose, the maltose, maltotriose, all of the simple sugars, and you're left with these long chain sugars. When you add a dry hop, you also are adding all the enzymes that come along with that dry hop. There's a couple different ones: beta amylase, alpha amylase, limit dextrinase, and amyloglucosidase are some of the major ones that come along. Each one of those enzymes acts in a different kind of a way. They cut this this long dextrin into smaller chunks. The ones that we're mostly worried about are the beta amylase and the amyloglucosidase. What the amyloglucosidase does is it cleaves at the end of these long chains and frees glucose. And what beta amylase does is it cleaves sort of close to the end and creates maltose. And that's actually the primary one that happens. Obviously, glucose and maltose are fermentable by your yeast. And so what happens is you get re-fermentation. And you get all the stuff that goes along with that. So you get additional ABV, you get sort of a lower final gravity, and that comes along with additional CO2 and additional diacetyl. And that's kind of the major thing that I think people are mostly worried about. I think a lot of brewers who felt they were being really responsible and had really good practices and they knew they had cleared their VDKs, they were feeling really good, were coming back to packages that had diacetyl, and it turns out they just hadn't finished their hop creep. So we're trying to figure out how to minimize that problem. So where do the enzymes come from? There was a big question for a long time. Is it actually from the hops themselves, or is it from bacteria that come along for a ride on hops? Because you are chucking, untreated vegetables into your beer. There was a really interesting paper that came out not too long ago from Matt Cottrell at Heavy Seas, where he has some really interesting controls where he uses weed because he needed something that was not a brewing ingredient that was kind of similar to it. So this paper is worth taking a look. But he basically showed pretty convincingly that it actually is enzymes that are coming from the hops. So take a look at that paper. So if we go deeper into hop creep, if we look at what kind of variables can impact hop creep, the first one is your yeast. There are certain yeasts that are just prone to diacetyl during your primary fermentation, and then prone during the hop creep phase. They tend to be lager strains, Chico, English strains. It's not correlated to flocculation, so it's not something about the yeast actually dropping out and just like becoming inactive. The cool thing is that now there are yeasts that are engineered to prevent diacetyl formation. So I'm sure you guys have heard about the ALDC enzyme. You can actually buy that enzyme and throw it into your wort if you want. But now there are strains that actually make ALDC inside the yeast, and so you can eliminate that point of contamination risk. You're not. It's one more thing you don't have to pay for. It's one more thing that you don't have to put into your fermentation. So the basic idea behind ALDC and behind the formation of diacetyl is that it's kind of a byproduct of your valine leucine synthesis. And what ALDC does is it basically takes one of the precursors and rather than allowing it to go to diacetyl, pushes it to a non-flavor pathway. So that's kind of all that ALDC does. So I mentioned that diacetyl production is strain dependent. This is some work that we did at Omega. We created a forced diacetyl assay. And so what we did is we took 15 Plato wort, and it's just diluted wort that was actually from our brew house, from all the wort that we actually use when we're propping your strains. Diluted it down to 15 Plato, and then at day 7, we added 1 Plato's worth of dextrose. So that's kind of mimicking the effects of when you put in hops and you get the cleaving of the maltose and the dextrose. Then crashed it early at day 9, so it doesn't have time to clear out the diacetyl, and then harvested for our gas chromatography, for Plato, and for pH. And so the results are here on the left. On the left of each one of these bars is the control, and then on the right is with the dextrose. So that's in the hop creep scenario. And this basically is just showing you the potential for diacetyl. So this is plotting diacetyl in each one of these strains, and you can see with this like forced diacetyl that various strains produce various amounts of diacetyl. Like we were talking about, the ones on the left here tend to be the lagers, tend to be Chico, tend to be British strains. So this first one I think is the Anchor Liberty strain, then Chico, then Fuller's. So some of the ones you kind of associate with diacetyl. One thing to keep in mind on here is your sensory threshold. I've got it marked here kind of around 40. It depends on the beer, what your threshold is on that. In lagers, you obviously perceive it a lot more easily than you do in ales. Lagers tends to be sort of in about 20, and ales tends to be sort of like 40, 50s where you can perceive it, so keep that in mind. I alluded to these ALDC strains. Lots of different vendors have these. It's not anything proprietary. I think some of the other companies call these diacetyl-free strains. Omega has them in the works, so keep an eye out for those. We've been testing all of these, and this is just sort of an example of what happens with these diacetyl-free strains, or these diacetyl-reduced strains. This is OYL 016, which is the Fuller strain. The dark line on the top is the parent, and the light line on the bottom is the ALDC version of it. And this is just tracking diacetyl over time. So we set up a flask assay, we set up 10 different flasks, and then just harvested one each day and measured the diacetyl. And you can see, as you expect, you make a lot of diacetyl during primary fermentation. The yeast sort of are getting sleepy, they're finishing out, and so they're still making diacetyl, but they're clearing it at a lower rate, so that's where you get this kind of little bump there, and then eventually they sort of clear it out. That's a pretty typical trend for yeast fermentations. But you can see for the LDC strains, it's not even measurable. Like, these things are awesome. They're great tools for being able to prevent diacetyl and also turn your tanks faster if you want. All right, so what variables impact hop creep? Another one is yeast attenuation. So if you don't have a whole lot of dextrins around at the end of your fermentation, you can't get a lot of hop creep, is the basic message here. So if you have a strain that has really high attenuation. So for example, on the right here, this OYL 205, that's our version of Sac Trois. It's called Tropical IPA. It's a diastatic strain. And so it's one that's already broken down a lot of those long chain dextrins. And so you can see that on the left is no dry hop, and on the right is dry hop. You can see there's not much of a change with the dry hop because there's not much left to chomp on. But when you have strains that have a lower attenuation, your potential for creep is much higher. So you can see this is just plotting your terminal Plato with and without dry hop, and just the kind of change that you can get with your dry hop. The dry hop timing really matters. So if you do an early dry hop, so like a day 0 dry hop, you can get your you can get your creep over with before fermentation is done. It's a great way to not have to extend your fermentations and be able to turn your tanks in a quick kind of a way. So if you look here, for each one of the strains, we have no dry hop on the left, which is the teal. The kind of royal blue is a day 0 dry hop. The light blue is a day 4 dry hop, and the dark blue is a day 7 dry hop. And so what you can see is if you do an early dry hop, that's kind of your potential for creep. That's as low as it's really going to get. You can see if you're doing that day 7 dry hop, that you've started to creep, but you know you have that same amount of hops in there, right? So you know you still have the enzyme, you still have the potential to go further down. And so what's scary there is that you might think that you're done, package this beer, and then that's still that potential. And that's where you get creep in your package. That's where you get volumes of CO2 you don't want. That's where you get diacetyl in your package. Your dry hop rate matters. So if you do larger dry hops at the end of fermentation, that can delay that creep even further. Basically, the idea here is that if you're adding these big dry hop charges, that you're basically impairing your yeast. So there's kind of two different pools of diacetyl that you have to deal with. There's the primary fermentation diacetyl, and then there's the diacetyl that's produced during your secondary fermentation. And the idea is that your yeast are so angry at you for checking in these high hop loads that they don't even make that second batch of diacetyl, and so you get a little bit like a slower decline in your diacetyl, but you're still going to get creep. This is a study that was by Chris O'Connor at Prost, and I realize it's a little hard to read because it's very small, but it's looking at the correlation between your attenuation and your dry hop creep with different dry hop rates. So on the top here, these orange ones are looking at your diacetyl, and then on the bottom are your attenuations. And the moral of the story is that with higher rates of dry hop, you get higher rates of diacetyl production. So that's kind of like what you expect, but only to a point, kind of like we were talking about with the rates. At some point, when you get to really super high hop loads, they actually see that with the 20 grams per liter, which correlates to about 5 pounds per barrel, you actually get less attenuation creep. And again, the idea is that it's probably a yeast health issue, and that's something that we're studying right now. So work is underway. The kind of hops that you use can affect your dry hop creep. So different hops come with different enzyme loads. This is work that was by Rob King at YCH. A lot of the hop providers are doing a lot of studies right now on kind of the diastase potential of hops. And the hope is that pretty soon that work will be published on all of the different varietals that you guys will be purchasing. The vague trend is that T90 tends to have higher creep and extracts tend to have lower creep. There's also variation dependence, so you can kind of see, for example, here that like Citra doesn't promote a whole lot of creep, but something like Cascade promotes a lot of hop creep. Other things that can affect it are how the hops were stored. So heat tends to degrade these enzymes. That's a tool that you could use later on. Also, just the farming techniques. So when they were harvested, how they were grown, all of that affects the enzyme load of these things. So what's interesting is this, for example, shows you a varietal difference, but you're also going to have batch-to-batch difference, and that's something that you're going to have to take into account in-house. It's something we'll get to a little later, but even within the same type of hop, you can get different kinds of changes, and so you're going to want to figure out which hop, or which batch you have and what your potential is in-house. All of this is summarized really nicely in a BA technical article on hop creep that Shellhammer wrote. So if you guys are interested in getting the details and having it actually on a sheet in front of you, check that out because it's a really useful resource. So methods to mitigate hop creep. We kind of talked about the potential for diastase in different hops. So you can just, by your hop choice, you can decide, you can minimize your potential. So you can use hops with high diastase activity, so lots of enzymatic activity in the whirlpool because the heat's going to inactivate it for later, and low diastase activity in your dry hop. You can target more conversion in the mash. So we said that if you have fewer dextrins around, that you get less creep. And so if you have a lower mash temperature, then you should get less creep down the road. Or you can do an early charge and just get it out of the way. Another way, obviously, is just ride it out. That's sort of the way that people were doing it back in the day. Just do your regular processes and make sure you're clearing your VDKs down the road. You can do it by preventing with a cold, short dry hop. So go through your entire fermentation, crash your beer out, get it cold, take your yeast off, do a real quick dry hop. That one's a little risky because if things get warm again and you have leftover yeast in there, if you have leftover enzymes in there, you can get re-fermentation, but it is an approach that people have taken. I personally wouldn't recommend it, but it is an option if you are in control of your cans at all times and you can be really, really sure that people are drinking it fresh. The other way is to pasteurize or inactivate your hop enzymes somehow. Options for that are you can do some sous vide trials. Obviously, you have to make sure that you're not degrading the flavor of your hops, but that's an option for degrading your enzymes. You can also go with a super low flash pasteurizer, like a quick one, to try and inactivate your enzymes. It's just putting that all into cartoons, so you can limit the potential with an early dry hop. You can ride it out with your typical kind of mid to late fermentation dry hop, or you can kind of wait and do a quick cold one or pasteurize. So ways for you to predict hop creep. So like I alluded to, there's batch to batch variation. Like how do I know that which ingredients I have in house and if the ingredients I have are gonna have hop creep? One thing you can do is you can measure the diastase activity in your hops, so you can figure out which hops you can use where. So that, like I said, some of the big companies are looking to add these kind of things onto their spec sheets, but there are ways you can do it in house, and we'll go through some of those. The other way is you can look at each one of your beers and just do some trials and measure your final attenuation and do some sniff tests. So I'd encourage you, it doesn't take any equipment, just set up some flask fermentations and add in the hops you're using in your flagships and do some sniff tests, do some gravity tests, and then see what happens. So as far as measuring diastase activity in your brewery, there is a method in the ASBC. It's for under malt, it's for diastatic power. The idea behind it is that you take either a starch substrate, like some kind of a dextrin, or a commercial beer sample, and you incubate it with hops, and then you either use HPLC, UV-Vis along with an oxidase assay, a glucose oxidase assay, or we've discovered that you can use a blood glucose meter, like for diabetics, that you can just buy at CVS. So you don't have to have these expensive equipment in your lab in order to do this, and I'll go through real quick how you can do that. So the idea behind that is you just find starch. In our case, we actually recommend that you use your beer because that's what you really care about anyway. Add your hops. We do it at about 2 pounds per barrel. You're going to add sodium azide to prevent additional fermentation. Basically, that just inhibits the ATP pathways in yeast, so you're not going to get additional, it depletes them of energy. Incubate it for 2 days, and then you use this blood glucose meter. So all it is it's like a little handheld machine that you put a little strip in. You take a droplet of your beer, put it on the end, just like you would do with blood if you were a diabetic, and it gives you a reading back. And you can correlate that back to dextrin amounts. Then, of course, it's not just glucose, it's not just dextrose that you're looking at, it's also maltose. So what you have to do is you have to digest your maltose into dextrose and kind of do the same thing and repeat it. There's an easy-to-buy enzyme, you just go to Megazyme, there's a buffer that comes along with it. Do another incubation and then measure your glucose again. Basically, you add those two things together, and that's your potential for creep. On the right here, you can see we did this assay in using both just dextrin, so a starch source, and then just 4 different beers that we bought off the shelf. And you can see the trends you see across all of the different media. You can see that in our case, the Cascade we had in our hands had a lot of potential for creep because there's a lot of maltose plus glucose that was made by the addition of the Cascade, and then lower for the Crowd Cascade and the Citra. You might see different trends in your hands. We see that Cascade is high, that's kind of what YCH saw, but you might not see the same results in your hands, so definitely check it out. This is also a great way once you have packaged beer, once you have your beer in package, to test to see if it's stable. So the same way we bought stuff off the shelf, you can test your package and see whether or not there's a risk for continued fermentation. So you can test your glucose, test your maltase, kind of see what's in your cans. This, by the way, was a really cool collab we did with WeldWorks. It's Mega Omega, and it was with Violized Strains, and then that Mega Motueka that has Phantasm in it. I didn't want to put somebody else's beer up here when we were talking about risk of fermentation and contamination, so that's why that's up there. So cool, we learned a lot about hop creep, and now I'm going to go a little bit into haze, because that's one of the other major things that we need to talk about when we're talking about what kind of yeast we want to pick and dry hops. So we've done extensive work on haze and trying to make stable haze and figuring out what strains do it. I'm not going to go into too much detail on that because I know we've talked about it for the last year and you guys have probably seen that talk, but just really quick to set up one graph that shows kind of our haze positive strains and then haze neutral strains. We developed a flask assay, very similar to what we were doing before. So we pulled off 15 Plato, 2 row wort, same thing off of our brew house. took all of our strains, for example, London 3 or British 5 is one of our haze positive ones. Chico is kind of a haze neutral. Pitched at a rate of 10 million cells per mil, held it at 70 degrees, did a 2 pound per barrel dry hop. And then we just determined, or we just did dry hops on different days. So right at knockout, day 1, 2, 3, 4, day 7, and then a double dry hop. And then centrifuge the samples, so it's not yeast in suspension, it is stable haze in suspension, and then measured haze. So this is sort of a picture of what these things look like, just as an example. So on the left, we've got the British 5, which is a haze positive strain. On the right is Chico. And you can obviously see with these mid to late fermentation dry hops, how you get hazy samples. One of the more interesting flasks here is this one. So that's an early dry hop on London 3. So the early dry hops, I know for a long time people were talking about getting your hops in as early as you can to make sure you get biotransformation. That actually is a negative haze producer. So it's a way, if for example, if you have like British 5 or one of these thiolized London 3 strains in your brewery as your house strain, it's a way to make sort of a pseudo West Coast beer, like more a clearer IPA, is to add early hops because it promotes clear beer. I know in my brewery, I definitely managed to make clear London 3 beers, and I was baffled because like the whole world uses this for hazies, and I realized what it really was is my whirlpool load was too heavy, and I was transferring too much hop material into my fermentation, and it basically was like a day 0 dry hop, and that's why I was getting clear beer. So that for me, when I started Omega, was like really eye-opening. I was like, that's the variable that I didn't realize. So we went through all of our strains, and these are the ones that came out as haze positive. A lot of the typical ones are there, so the British 5, Voss, things like that. Like we kind of alluded to earlier, there's some surprising ones here, some of the Kolsch's, the West Coast 2s, things like that. What these all have in common, well, not all in common, but a lot of these have in common is that in their history they were top cropped, which is kind of interesting, like Hefeweizens are in that category. But these are what you want to use for hazy strains. So to summarize, your dry hop timing really matters. Your strain choice really matters. You get your haze is reduced with an early dry hop, and your stable haze is increased with the mid to late fermentation dry hop. That's plenty of time for you to still get biotransformation. So you don't have to worry about, am I going to get my fruity flavors? You're in contact with the yeast for plenty of time. You can still crop your yeast when you do that mid to late fermentation, which is great, because that was something that was really an issue when people were doing their early dry hops is, am I going to harvest this with all the hops in there? How's that going to affect everything? And the cool thing is it still allows you to mitigate hop creep. So you can do your mid to late addition, and that's still early enough where you can start to get your hop creep going early. So as I started to kind of allude to there, all of these questions all kind of come in and they interplay with each other, right? So depending on what your goals are, you can get different advice about when to dry hop, when to harvest, how all this, when am I supposed to do all this kind of stuff. So I kind of want to bring that all together for us now and go into some just sort of like basic good practices for how to handle your yeast. Thinking about your repitching best practices, the biggest thing is be consistent about it. Make sure that you're tracking your timing, your viability of your yeast, your fermentation, your gens, how long you're storing it, and whether there's any contamination in it. As far as determining pitch rate, this is something you can always ask us about. I think different vendors have different recommendations based on kind of their best practices. Obviously, it depends on the temperature you're planning on running at, your Play-Doh, how much oxygen you're adding, how much nutrients you have. Also depends on what kind of flavor profile you're going for. So some strains like to be stressed out. They give off good flavors when you do that. So take those things into account. Your pitch rate can vary anywhere from about 0.5 to 2 million cells per mil per Play-Doh. I know at Omega, I think we recommend about 0.75 per, which is a little lower than some people do, but we found with our yeast health it's okay. I've heard some recommendations that for some of these thiol strains that you want to go a little bit higher. I think that's great in order to make sure you have healthy fermentations. Your pitch rate's also going to matter depending on your strain. So Kveiks can tolerate a much lower pitch rate, though I will say we don't recommend the teaspoon into a barrel that a lot of people were doing back in the day. Just a regular pitch rate on those. then Belgians, then English or American strains, and then lagers you want to pitch the highest, so closer to that 2 million per. As far as how you're going to measure that, the best way is live cell counts. That's expensive. Mag meters are awesome. These perfect pitches are great, but we can't all afford that. So other than that, going by weight or by volume is fine. The biggest thing is just to make sure you're paying attention to your yeast. So track all your data, track where it's coming from, your gen numbers, whether it's cleared diacetyl, harvest dates, things like that. Do your contamination checks at various points throughout. This was some daily cellaring records that was from a brewery that the R&D director worked for previous to Omega. And this was really eye-opening to me, mostly because of the green line. So that's the viability over time. And you can see that it starts to decrease from 100 on like day 5. So I don't know about you, but like I was harvesting later than that. I was, for like West Coast, back in the day, I was letting it stabilize at a Plato and then, maybe doing like a soft crash and then getting my yeast off and then doing a dry hop. I was way too late. I was in this like 70%, 50% range. I had no idea. I thought I was still healthy. What this tells us is we have to harvest a little earlier than we think. At least I needed to, which is actually kind of great if we're looking at some of these techniques we were talking about. That kind of dovetails in with adding some mid-fermentation dry hops in order to A, mitigate dry hop creep, and B, get your haze going. So the summary of that is that for your harvest, you probably want to be harvesting in that kind of like 5 to 7 day range. It's when your yeast have started to flock out, so there's plenty at the bottom for you to work from. You don't have to do a soft crash. There will be plenty down there for you to work with. You still have good viability at that point, and obviously you should be almost clear with diacetyl at that point. Whatever's left in suspension is plenty to clear diacetyl. You don't have to worry that you're taking out your workhorses. It'll still clear out. I also realized, by the way, that this is wrong. That was just a bad copy and paste, so I apologize for that. If you want to do an early to mid fermentation dry hop, so if you are looking for, for example, to clear out like a London 3 beer, or if for some other reason you want to chuck in your dry hops early, obviously you need to harvest before you throw in those dry hops. That does mean that you're at this stage here where you don't have very much yeast down at the bottom. In that case, we advocate for some sort of a top cropping method. This was an interesting paper that came out by Jessica Young. She was at Bearded Iris at the time, and it was a technical quarterly in the MBAA website. And she put together a system that I think works pretty well, though I would advocate for it being closed down here and actually having a valve. But the biggest idea is that you're hooking up a sanitized hose to your vent arm and then bubbling through CO2 to get the krausen to kind of overflow in your vent, and you can actually harvest that into a brink, which I thought was a pretty good idea. People have also just made sure to fill up the brinks, or excuse me, their fermenters pretty high and just caught the overflow. That's another way people have done it. You have to be pretty precise about how you fill your fermenters, and you have to know your strains pretty well to know how much krausen they give. That's another approach. For the most part, I think we can kind of get away with not doing those early dry hops because it does dovetail in, like I said, with haze production and your creep mitigation. So don't dry hop beforehand. Do your repitch and then your dry hops afterwards. We advocate for cone-to-cone pitching. I'm sure most of you know how to do this, but I just wanted to put in here in case you don't, so that it's something we have for the record. Make sure and do all of your yeast cell counts and your contamination checks before you pasteurize all your hose work. That's definitely a mistake I've made, or you have to repeat it. But otherwise, we advocate for cone-to-cone. The easiest way, and I think what most people are going to be doing, is repitching by volume or weight. What that requires you to do is to dump trub and get a good sample of your yeast that has good sensory, degas it, and then do a cell count. The easiest way to do that is with a hemocytometer, which is on the right there. And I'm sure you guys have gone through all of this. It's all online. This is the math for how you actually go from a cell count into either by volume or weight pitches. So that will be in this presentation if you guys want it later. But I'm not going to go through all that because that would suck. So, all right, as far as repitching, like how many strains can you keep in-house? It depends on what kind of strains you're using is the moral of the story. So if you're doing Kveik's, they tend to have a quick turn time. So they tend to be in and out of the fermenter in 14 to 18 days. So if you're thinking about, when you have a healthy harvest and, what the kind of the sequential progression is. You pretty much only need 2.5 fermenters per strain for Kvike. For standard ales, you're looking at a residency time of about 18 to 21 days, so you probably need about 3 fermenters per strain. And for quick lagers, looking at like 21 to 28 day time and like 4 fermenters per strain. If you are a traditional German brewery, you obviously are, your residency is much longer than that, and you'll need a lot more fermenters or horizontal lagering tanks, which is awesome. As far as storage, just need some kind of clean vessel. Brinks like on the right there are most commonly what I've seen used. The biggest thing is you want to make sure that they are easily CIP-able. It's great if you can steam them. We steam all of our fermenters at Omega before we put things in there to make sure that things are contamination free, and I think it's the best way. You need some way of making sure that you can measure fill volume or weight. And it's great if you can have a mixer in there. The biggest thing is because you want to, as you have your yeast stored, you want to be able to take samples over time and check viability. The hard thing is if that is segregated out into different layers inside that brink, it's hard to take a good sample without having mixing. So we definitely advocate having some kind of a propeller or, kicking this thing around the warehouse before you take your samples. The biggest thing is to make sure you're harvesting your yeast to your peak viability, so that day 5 to day 7 that we talked about earlier. We don't advocate for yeast washing, acid washing. It doesn't seem to have any effect. It's just one way to introduce contamination, in our opinion, and it also is stressful for the yeast. Most of the time, if you have good sanitation practices in your brewery, you shouldn't need it anyway. Store it in your cooler. Store it as close to 0 Celsius as you can without freezing it. Keep it with a little bit of CO2 pressure, but not too much. You don't want to have a bunch of head pressure on there because that makes the yeast angry. Storage time is going to matter depending on your strain, right? So we say, kind of between 2 days and 2 weeks. Really, really, really matters in your strain. So the house strains, I had like a Belgian in-house, I had a Chico in-house, I had a London in-house. I could keep Chico for about up to a week. That Belgian, I can only keep 2 days. Most of that is just, it's sensory, it's viability checks, it's just knowing your yeast. We don't advocate for feeding throughout. The idea is to put these yeast to sleep and let them just kind of chill. If you want, you can do feeding right before you use this stuff. So we just advocate for using, kind of a low Plato wort. You can pull some off of your brew house and dilute it down in a sterile way. That's one option. Or you can, make a DME starter and use something like that. Cool. So to conclude, there's a lot of options out there. Hop creep happens. Haze is great, and there are ways to make them all kind of work together. So, if you're thinking about like how you're dry hopping your yeast, you can kind of see if you make choices to add early hops, you can see the consequences on hop creep, haze, and your repitching. So you're going to kind of get through your hop creep super fast. It's going to be lower for your haze, and you're going to have to top crop. If you throw in your dry hops at mid-fermentation, you're going to deal with your hop creep well. It's good for haze. Still have to kind of top crop. And late, you have to worry about your hop creep, but it's going to be really great for your haze, and it'll be really great for your repitching. So moral of the story is figure out what works for you. Figure out, which strains work for you. I mean, it may be that you've loved London for a long time, but there might be another haze option out there that might, fit all of your needs a little bit better. And just make sure that you have good practices while you do it. And again, so remember you have options. And that's about it. Cool. Thanks, kids. I'm happy to take questions. Yeah.
So, I think that you had mentioned that you were loading up your whirlpool to have
Yeah.
Think about how many pounds per barrel did you notice?
It's going to depend on your whirlpool and how much you're putting through your heat-X. So I didn't have a good dam on my whirlpool, and I was probably pulling too much through. You shouldn't have been pulling up through as many as we were. I was in a kind of strange situation where I was in a brewery that didn't have racking arms. Our tanks were 60-barrel fermenters that were from Sierra Nevada. And the way that Sierra Nevada used to dry hop is they would hang bags of fresh, like full cone hops. And so they didn't need it because there wasn't a bunch of garbage in the bottom. So I was trying to, replace my early dry hops with the Whirlpool editions for a while to try and get that hop load in there somehow. And it just, you play around with stuff. Sometimes stuff works, sometimes it doesn't. but that was a lesson that I learned that way. I think it was probably 2 pounds per barrel for us, but again, it totally depends on the geometry of your whirlpool and how much you're pulling in. Yeah.
Have you done any case studies on viability of feeding a brink, but consistently pulling away and re-feeding it? You know what I mean?
I
used to
personally
bike, but I
have
feed
not.
it and take away constantly. You know?
Right. I mean, I understand. So the idea there is that it's not swimming in its own leftovers, which seems like a good idea. I suppose in that way you're sort of taking it through more gens. So I could see there being genetic drift, perhaps, that might be a problem, because you're essentially just like putting it through more and more fermentations. Right. So I think that probably will accelerate the timeline on kind of exhausting the useful lifetime is my best guess. I have not done those studies personally, and we have not addressed those in a while at Omega. Basically, our knowledge is based on the cubes that we produce for you guys, and how kind of the best way that they like to be stored, and so that the cold storage is what we found is best for viability. But yeah, we haven't gone through like feeding trials for that in a while. Yeah.
I have a question about whether you guys have any opinions or speculation on what it is in hops that stimulates these particular yeasts to produce haze or not, and whether there's a relation of how that relates to different hop products that might have less polyphenol content.
Right. All of those are studies that are underway. I don't think I'm at liberty to talk about them yet. It's definitely like an active part of research, because I think people are super excited about haze, right? And there are a limited number of strains, and so kind of teasing out what it is that we're doing so we can get back to methods of maximizing it, moving around haze into different strains, all the kind of like pipe dream ideas that you can come up with. We're thinking about it. But yeah, I don't think I'm allowed to talk about it yet. Sorry. Yeah.
Question's too good.
Using like an incognito whirlpool instead of doing the dry hop, which affect the harvesting of yeast, and is that similar to early dry hopping as far as the clarity of the field?
So using an incognito product in the whirlpool is a great option. It shouldn't affect harvesting yeast. The biggest thing about harvesting yeast after your dry hop is that you bring all that vegetal matter along with it, and you're not getting that with an incognito product. As far as its effect on, did you ask about hop creep?
The haze formation.
Oh, haze formation. Ooh, we have looked at haze formation with all of the different products. So comparing the T90s to cryos to some of the extracts. It's been a while since I've thought about that. Let me come find me afterwards. I have those graphs. I don't want to misquote what the actual data is. I don't remember off the top of my head. We have that data. Come find me. Yeah.
So when it came to hop creep and dry hop timing, you were saying, with a very early dry hop, you're getting hop creep started basically sooner. So if you're in a situation where, let's say, you're going to Albany for 3 days, and that normally would be when you were dry hopping the beer, right? Can you avoid hop creep by doing a small charge early on, and then later on doing a full dry? But is it obviously with more hop pounds, you're talking about more enzyme getting in there? Can you eliminate that with an early small dry?
I think it totally depends on how much enzyme was in your hops, because it totally depends on whether or not the enzymes that got in there early are sufficient to get the job done, right? And so it's a thresholding thing, and so I think it's completely going to be situation to situation dependent. And without having numbers, I don't think there's a way to predict that. I mean, it's not going to hurt. I would try and get out of the way.
Try, say, 10% of my dry hop.
Yeah.
And see what happens.
Yeah, I mean, just keep in mind, if you are looking at hazy beer, just keep in mind that you might start to have effects on that. And, obviously when hops go in at different times, there's different flavors, things like that. So, make mature choices as a good brewer, and I'm sure it's all good. In the back?
I guess I understand the enzymatic issue for hop creep. What are you associating as the actual fermenter of hop creep? Is it the yeast that is in suspension itself, or is there any microorganism or hops that you're concerned about?
We attribute the fermentation to the yeast. I mean, certainly the diacetyl production suggests that, it's probably, it's a yeast-based thing. Certainly, there is a small load of bacteria that comes along with your hops. It was eliminated as the source of the enzymes, but it doesn't mean that it's not chewing on some of those things. I would assume that the yeast would outcompete anything that's there. So the yeast.
Thank you.
Cool. Well, thanks a lot, guys. If you have any questions, I'm around.